Hey everyone, today I want to show you something I have been working on. This little device right here, at a first glance, it might just look like some LEDs and a tiny speaker, but this is actually the core of my project called Sentinel AI system. It's a smart notification and security system that combines lights, sound, and automation. So, let's see this device right here. So, there's a addressable LED light ring that I have used here, and there's this tiny speaker right there. Okay. And at the back of it, there's nothing much, just a USB header so that I can just plug it in using a normal power adapter that we use to charge our mobile phone, and it's just a micro B USB really. So that's the device. So at a first glance, it just looks like some fancy lighting device, but it can actually connect to my instance of NA10 that I will show you briefly. So the device itself is just looks like that. It sits on your table like that. Just focus, and let me show you just how it looks like when it's lit up. Looks like that. Or you can have some effects. Of course, it's multiple colors are there, so you can have almost any color. All right. So, what are the use case and how it connects to the internet and how it talks to NA10 and what it does? Let's move to my screen. All right, we are on the screen now. So first of all, what we need to do is enable these two instances over here. So I have Docker container over here. So first instance that I will be booting is NA10, and the second is I'm using EMQX. So this is MQTT a broker. So let me start these services, and it will take a minute to boot up. All right, let me see if it's available. Not yet. Yeah, it should be available at port 5678. All right, booting up. All right, so we are at the desktop. So let's see what's happening here. So we have this little device over here. I have my NA10 instance over here. What's happening behind the scenes is this little device can actually connect to the NA10, and to make it connect to NA10 I have used a protocol called MQTT. So this protocol is very popular with the IoT devices because of its low latency, and basically it has a very you can transmit without having a very much big of overhead. So let's see some automations that I have made. The first one is called urgent email notification. Alright, so it has loaded. So at a glance you can see the complete workflow that I have automated. So at a glance it looks like much, but it really is not. So let's start. So NA10, there are some different type of nodes, and every item you see here is a node. So there are trigger nodes. So trigger nodes are used to start a workflow, and there are worker nodes that do some tasks basically. All right, so let's see this Gmail trigger node. So it is connected to my Gmail account using OAuth, and it is polling my emails like every minute, and whenever it receives a new email, it will just trigger this workflow basically. So this is a sample email that it has pulled the last time. So after that it goes to an AI agent. So for this AI agent I have used Google Gemini chat models. So what it is doing is it is looking at this email and determining if that email is urgent or not. So looking at this email, there is a system prompt, there is guideline, and in the output it has to return true or false based on its analysis. So for the message user I am passing the subject, the snippet, the from. Okay, as you can see the results here, and for this is the system prompt. So there's also one structured output parser. So this is the schema that I have provided. So this AI will always output in this schema basically. If I want, I can add a memory to this AI agent. I can use any database I want, and I could also add support for the tool output. So basically AI agent can call other tools to make any decision. For example, like it can connect to Google Calendar to see if there is a matching calendar event for that email that I need to look into, and then consider if it is urgent or not. So that's possible here. And after that there is a edit field. So this is just a manual mapping. This is not needed in the production workflow. It is here just for this demonstration. And then, like, if AI agent decide that this email is urgent, so there's a if block, so then this true flow will get executed. So basically there's a sequence that I will show you, and if it is not urgent, then there is another sequence that I'm gonna show you. So let me just switch to my device over here. Alright, we are recording. Okay, so for now, let's set it to true. So I'm just overriding the response from the AI agent to true always, just for this demonstration, so that I can demo like both flows, because I cannot receive an urgent and not urgent email right now. So just let's execute this workflow. The Gmail is checking for the last email. AI agent is parsing using Google Gemini chat models. There it is. Let's see that again. Alright. I think the volume is a bit too low. Let me just increase the volume. So it's 20 right now. Let me just make it 25, so it's a bit louder. Let's see that again. Yep, that was louder. Okay, so just let's flip the switch. Let's make it false. So whatever the response, I'm just making it false so that I can trigger this false workflow. Yep. So different sound got played and different lighting effect were shown based on this false flag. So let's look deep into these nodes over here. So from this if block will return urgent true or false, like that. Last time it returned false. Okay, this edit field is not doing anything much. It just turns that true false to on and off strings, because MQTT expect these strings rather than a boolean value. So it's just mapping that true or false value to on and off. So this is basically JavaScript. And then there is my MQTT broadcast over here. So I'm publishing the message on this topic. So basically I'm publishing to all available devices and send the input. So that means this output right from the last node, this on and off, will be sent to this. Since last time it was off, so that's why this flow got triggered. I can also like execute this independent node, but it will actually pass on the input data. If I want to override it, I can override it here. Like if I just forcefully turn it on, it will turn on. I will just send this data from the pass node. So there is a lights on sequence, then there is a play sound. So here I have provided like play track number 7 on the SD card. Okay, and then it waits for 5 seconds, and after that the light turns off. The music automatically stops when the track ends. The light turns off after 5 seconds. For this false workflow, play soft sound. So there is a number 6 track that I'm playing, which has a softer sound, and then there's a light breathing effect. So this is the API basically sequencing, the LED sequencing. Uh, the brightness, I can change the brightness, it will be more brighter. So it goes from like 0 to 255. 255 is the maximum, and after that there is again there is a wait of 5 seconds, and then the light turns off after that because the hard-coded message falls off over here. Yeah, so that's pretty much how it's working. Let me just make it, yeah, maybe false, it's not urgent. It triggers, AI agent checks for urgency, and a workflow gets executed. uh, let us increase the brightness like to maximum to 50. Save it. Let's trigger, let's see if that increases the brightness. Yep, definitely that's brighter now. So that way you can adjust the brightness. Alright, so that's one flow. Let's switch to the other flow. Sorry. Okay, let's see how it works with the calendar. So similar to what we have seen with the email, it can also get a trigger from calendar. So there is a very simple workflow over here. So it is connected to my Google account, Google Calendar, and it's polling for event for every minute. There's my office account right there. All right. So if I execute it, so yeah, so different music we can hear. Let me just reduce this sound a bit. All right. Yeah. Let's do that again. Yeah. So what's actually happening is we don't have to like manually execute this workflow. I can just like enable this in production mode, and when it is enabled it will actually stay connected to OAuth client using the OAuth client, and will try to poll for events. So whenever it see a new meeting started, so there are multiple events that you can trigger it on. So I have like event started, so whenever there is a new calendar meeting that has started, it will start the sequence. The lights will turn on. Okay, and here the track 4 will get played. Okay, then again there is a wait for 5 seconds, and then light will turn off. So this is a very simple example of how we can make it trigger on the calendar events. Alright, so here we are in the third workflow that we have here. It is the security system one. So basically what I'm doing is I'm detecting events from CCTV cameras, and when the camera has detect an event, I'm sending that event to N8N instance, which is then sending those events to this device, which is turning on the lights and also turning on our alarm. So how it is doing is it is using this webhook. So this webhook has this test URL and this production URL. So I can just fire like this test URL from Postman to simulate an event from camera. Okay, so here's my Postman, and I will just start this workflow. Okay, so now it has started, and I just need to fire an as a sample event. So there is a sample event that will be triggered. So if I send it, just look like what happens. Okay. Okay. Oh, sorry, I forgot to turn it on. My bad. Okay. So let it boot up. I think it's booted up. Let's try that again. Okay, I need to execute this workflow again. Okay, it's listening. Let's send the event. There it is. All right. So for this sequencing, over here I'm playing this track number 33, which is this police siren that is being played. Then there is this lighting effect that I have written here. So it is the sequence of that red and blue lights that you just saw. And there is a wait for 5 seconds. Oh, sorry, it's 15 seconds now, and then just light turns off. So the question is how the camera will invoke this webhook. To do that, I have made this repository. So this is a Node.js application that I have written just for this application over here. So what it does is you can just click on it. You can run it on your local machine. You need to provide the IP address of your camera and the IP address of your N8N instance. Then it will start, like, it will communicate with your camera. It will start a subscription with your camera. It will keep renewing that subscription, and it will pull the events out of it. So if your camera is having these AI capabilities for motion detection and people detection, intrusion detection, and on all sorts of other detections, so those events will be pulled from here. If not, you can also run some local models like YOLO models, but for that you will need some additional hardware, because doing it on software side just on the CPU is very intensive, while having a dedicated module for that will make it very easy. All right, let me just show you like how you can utilize this repository. So let me just open. Yeah. So if I just do npm run dev, I have already configured like everything in env. So if I like show you the env example 5, the most thing that you need to do is you need to have to change this IP address. You need to point where the camera is. Most of the camera uses 2020 port, but you can check for your camera. You'll have to provide the password and the username for your camera, and then you will also need to like provide the IP address of your host. So this is the system where N8N is hosted. It can be local, it can be on the internet. So you can also provide a domain name over here and leave these just events, or you can change the endpoint if you really want to. So there are two methods to pull the events or to push the events. So I prefer the push method because it just declutter your network calls instead of polling again and again. So yeah, it does support that. Also there is some throttling support. You don't want to be bombarded with like motion events, so you can just throttle it down. And there is some renewal configs that I have provided support for. One more thing, so if it is like failed to renew the subscription, it will actually call your webhook with an alert like camera is missing or like camera is not responding. So that support is there as well. So once you have like configured your env, you can just do npm run dev for development server with logs, or for to prod you can just build using TypeScript. So there is a build command, and after that you can just start as a Node.js application with you won't need TypeScript in the runtime. Yeah, so you can just build and then you can just start. Okay, so it has started the analytics, it has started everything, and it is listening for the events. So let me go in front of the camera and you should see the event in the real time. All right, so there are the events, as you can see. So it has detected like multiple events. So motion detection was there, people event was there. Of course it was throttled down, and not all these events were sent to your webhook. Only a few will be sent, that you can see the logs of. If you just go to the execution, so this test icon demonstrates the test we did. So this is non-prod, and the execution that does not have this icon are the production one. So these three webhook were invoked. Of course all these three did not hit the alarm. I'm only hitting the alarm on the people detection. So if I open this one, so was, yep, so this is one where the people was detected. So that's why we saw that alarm. Okay, to make all this work, I'm also running one instance of this broker, this EMQX server, and here's the dashboard for that. So if I go to monitoring, cluster monitoring, we can see there is one device right now. There are 6 subscription and 6 topics. Yeah. So even if your device goes down, it will keep those messages as in pending state. As soon as your device comes online, it will just push all the message through. All right.